Hey, hi guys. Can you please confirm? I'm audible. Just confirm once in a chat. Hey Jaya, where is Ravi Teja?
Yes, I is joining 2 minutes.
Okay, fine. So let me share my screen and then we can start. Fine. Okay. So, fine. So can you please confirm? Is my screen visible? Yes.
Yes, sir. It's visible.
Okay, fine. So Jaya, shall we start?
Yes, sir. Ravi also joined.
Okay, fine. So let's start then. Okay. So again, let's continue with the transformer. Okay, let me open the research paper as well so that parallelly that we can attention all you need. Apart from this one, let me open my sheet as well. Fine. So let's continue. Okay. As we are learning a transformer. Okay. So we all know in a transformer, what we need to do, we have the two block. First one is a encoder. Second one is a decoder. Total two block that we have. First one is a encoder block and second that we have that is called decoder block. So here in the right hand side that we have the entire architecture. This is called the decoder block and the first one that is called encoder block. Again, in a encoder, in a transformer that we have a total 6 stack of the encoder. Total 6 stack of the encoder. So one top of the another. So 1, 2, 3, 4, 5, 6. Okay. So what happened here in this particular encoder? First of all, whatever the input data that we have, whatever the input data that we have. So let's say we have some input data that is called I love apple. So this is the input data that we have. So what we can do, whatever the input data that we have, first that we can encode this particular input data. So first that we can do the encoding. After that, whatever the encoding that we are going to do, those particular encoding that we can assign as a position. So we can say the positional encoding that we can do. First that we can convert into the embedding or encoding, embedding vector we can say, and then we can assign the positional embedding. After assigning the positional embedding, whatever the data that we are getting, let's say that we are getting a data in a vector. Okay, so the vector size that we have here that is called 512 vector size for each word. For I, we have the total 512 vector. For love, we have the total 512 vector. For apple, that we have the 512 vector. So for each word, we have a total vector size that is called 512. Now what we can do, whatever the vector data that we are getting per word, each word, those particular vector data that we can send into the encoder layer. So whatever the encoder that we have, so let's say encoder layer 1, encoder 2, encoder 3, 4, 5, and 6. Total 6 encoder that we have one top of another. So whatever the input data that we are getting, positional embedding, those particular encoder data that we can send to the embedding one, like encoder 1, encoder 2, encoder 3, encoder 4, encoder 5, encoder 6. Now whatever after doing the entire processing through the encoder 1 to through 6, whatever the output that we are getting, this particular output that we send to the decoder layer. Now let's say here that we have 6 encoder. It means here we have the total 6 decoders. So 1, 2, 3, 4, 5 and 6. Whatever the output that we are getting here, this particular output that we send to our all the decoders. So decoder number 1, decoder 2, 3, 4, 5 and 6. Okay, so this particular context vector output that we can send to our all the decoder, and then this particular decoder layer, it will generate the final output. So I love apple, it means मुझे सेब पसंद है. This is the output that we are getting. In this way, the complete transformer architecture work, where we have the 6 stack of the encoder and the 6 stack of the decoder. Now in each encoder we have the two things. In each encoder we have the two things. First one, that is called self attention. Self attention. Second, that we have the feed forward neural network. These two things that we have. Okay, now we can discuss these two things in a detail. Okay, so now let's start this one. So here you can see, if I show you the architecture, the beautiful block here. So this is the high level architecture that we have, where we are sending a data in a French word, Jesus irudent, something like this is the French word that we have. So this particular data that we send to the transformer, where we have the two block. First one is a encoder and the second one is a decoder. So whatever the input data that we are sending, first those particular data that we send to the encoder, and then whatever the context vector our encoder generate, those particular context vector that we send to the decoder block, and then decoder generate the final output, that is called I am a student. So this particular output that we are getting. Now here you can see, in this way that we send the entire data. So first is the input data. Now under this particular transformer that we have the two things, encoder and decoder. Encoder takes the input data, do some types of the processing. Okay, where we have some base network that is called LSTM, RNN, GRU, and then whatever the context vector it generate, we send to the decoder, and then decoder generate the final output. Now here we have all the stack of the encoder and the stack of the decoder. So here whatever the input data that we have, one by one that we are sending to the encoder, first encoder, second, third, fourth, fifth, sixth, and whatever the context vector that we are getting, those particular context vector that we send to all the decoder, and then our decoder, it help us to generate the final output, this particular output. Okay, now as I mentioned, under the encoder that we have the two things. First one that is called self attention, second one that is called feed forward neural network. Okay, so now let's try to understand what is what is self attention, and how this particular self attention works. What are the things that we need to do under the self attention? Okay, so now let's try to understand this one in a detail. So self attention, it means whatever the data that we have, whatever the sentences that we have in our data set. So let's say that we have one data set where we have the millions of the record. Now from those particular millions of the record that we are going to talk about the single row. So in a single row we have some sentences. Okay, now from those particular sentences we can apply the self attention, so that we can focus on the particular word. We can focus on a particular word. So if I write one data here, so let's say here that we have the data like my self Shivan Kumar. Okay, so this is a total 4 word that we have. Now here that I'm going to write मेरा नाम शिवन Kumar hai. Now as you can see here that we are talking about the name. We are talking about the name. So in a NLP that we have one application that we have. Okay, one application that we have, that is called NER. NER, that is called name entity recognition. With the help of this particular application, that we can recognize any types of the name from our data. Let's say that we have the Wikipedia data. Okay, or let's say that we have one PDF data set, or let's say that we have the research paper data, or we have the book PDF. Now from those particular book PDF or the Wikipedia, we need some information, like we need the name, name for the particular like for the particular Wikipedia page. Okay, so let's say that we are using the Wikipedia page like Shah Rukh Khan. Okay, Shah Rukh Khan. So for this particular Shah Rukh Khan Wikipedia page, what I need? I need the name. Okay, I need the location. Okay, so where Shah Rukh Khan is staying. Okay, now apart from this one, whatever the other information that we need. Okay, so with the help of NER, name entity recognition, that we can fetch all those information from the Wikipedia page or the PDF or for the research paper or from the book PDF. Okay, those things that we can extract. Now same thing that we have here, as you can see. So name, as you can see, name. So with the help of NER, that we can recognize this particular sentence, myself Shivan Kumar. So here Shivan is a name word that we have in this particular entire sentences. Myself Shivan Kumar. So in this particular entire sentences, Shivan is a name, person name represents. Shivan is represent the person name. With the help of NLP, like NLP NER technique, easily that we can identify. But how our machine understand? Okay, so this particular Shivan that we are going to represent to this particular word or this particular word or this particular word or this particular word. Okay, so here self attention come into the picture. Self attention come into the picture, and with the help of self attention, that we can focus on the particular word in a sentences. To focus on the particular word in a sentences, that we need to calculate the score for each word. For each word, that we need to calculate the score. Okay, so what happened if I talk about the simple example? So in a neural network, what happened? Let's say we have the data like my self Shivan Kumar. Let's say this is the sentences that we have. Now let's say if I need to create the simple neural network architecture, and then based upon the architecture, let's say if I need to pass this particular data to the neural network. So how we do usually? What we can do, we can create first of all the simple architecture for the neural network, right? We can create the simple architecture. So let's say here that we have some, these are the neural network, this one that we are going to create. Input data that we can pass via this one, not like this one. Okay, so let's say here that we are going to pass. Okay, so let's say that we are going to pass the input data. Okay, so from here that we are going to pass the input data, we are going to pass the input data from here, from here, from here, from here, from here. This is the input layer that we have. This is the input layer that we have. I'm talking about the simple neural network. Okay, now after that, in between that we have the hidden layer. So let's say that we have here, we are going to create some hidden layer. Now what happened? Whatever the input data that we are going to pass, let's say that we are going to pass the first word that is called my, then self, then Shivan, and then Kumar. These four words that we are going to pass via the input layer. Now what happened? Whatever the data that we are going to pass to the hidden layer, in this way that we can pass the entire data, right? In this way that we can pass our entire data, right? Now what happened here in between, whenever we are going to pass the input data to the hidden layer, in between that we have some weight here, some weight, random weight. We can say the random weight that we have. So what we do usually, we can do the multiplication input data into weight, whatever the random weight that we have, and then we can add the biases, additional biases that we can add, and after that we are getting some types of the output. Let's say that we are getting some types of the output. Now what we do usually, this particular output that we can calculate the loss. Okay, if we have the high loss, in this case we can do the back propagation, where we can update the weight, and based upon the weight updation, then we can again calculate the final score for this particular output. If this is match, then we can say yes, this is the correct output that we have. Let me give you the simple example. Let's say that we have the two types of the data. First, that we have the cat image, and second that we have the dog image, cat and dog image. Now what we are going to do, so first of all that we are going to convert the images into the pixel, and those particular pixel value that we are going to send one by one via the input layer to the hidden layer to do some types of the calculation, where we are using the weight. And based upon those particular calculation, then we are going to calculate, okay, so whatever the image pixel value that we have passed, okay, so this is the cat or this is the dog, right? So let's say if we are sending the cat image, but here output that we are getting a dog output that we are getting, in this case what we need to do, we need to update the weight, and based upon this particular weight updation, again that we need to do the backward propagation, and after that again that we can get the final output. So let's say again that we are sending the cat pixel images, and then we are getting the cat as a output. In this way that we can say, okay, so now we are getting the correct output, so this is the correct application that we have, right? So in this way that we do the entire calculation. So same thing happen here in a self attention as well. So what happened, whatever the input data that we are going to pass, first of all that we need to do the multiplication with the weight. Till here clear everyone? What is the motive
Yes, sir.
behind the self attention part is clear. Why we need the self attention? To calculate the score for the particular word, so that we can get, or our machine can get the idea, okay, this particular word Shivan represents to this particular Shivan word. Okay, else it might be, we can say, or our machine say, okay, no, this particular Shivan represents this particular self, or this particular Mai, or this particular Kumar, right? So that's why we are going to calculate the score for each word, and based upon those particular score, we say, okay, this particular word represents the another word that is called in Hindi Shivan represents this particular English word that is called Shivan. So at the end, self attention that we need to use to calculate the score for the particular word, so that we can focus on the important word, whatever the important word that we have in our entire sentences or in our entire corpus of the data. Clear? Till here? Yes?
Yes, sir.
No?
Yes, sir. Clear.
Jaya? Ravitega?
Yes, sir.
Clear, sir.
Fine. Now, after that, let's do the mathematical calculation. How we can calculate the self-attention. Okay. So, whenever we talk about to calculating the self-attention, we need to use three things, or we need to calculate the three things. First, that is called key. Second, that is called query. And third, that is called value. Query, key, and value, three things that we need to calculate. Now if I show you here, so as you can see here that we started bringing the like tensors. Okay, so whatever the input data that we are getting, how that we can convert those particular data into the embedding vector. So as I said, embedding whatever the input data that we have, let's say I love apple, so for each word that we need to convert into the 512 vector. So here you can see we have some input data that is called input data x1, x2, x3, where that we have G shows idiot, something like French word. Now what we are going to do, each word is embedded into the vector size of 512. We will represent these vectors with these simple boxes. Okay, so those particular 512 vector that we can represent as a vector. Now same thing that we are doing here. So let's say that we are talking about a first input data that is called G x1. Okay, so in this case what we need to do, we need to create a total 512 vectors. So I can say x1, x2, x3, x4, x5, and the so on 512 input layer I need to create, and then those particular vector we need to pass to the hidden layer, where we need to do the calculation first with the random weight, whatever the random weight that we have in between the input layer and the hidden layer. Okay, whatever the random weight that we have in between the hidden layer and the input layer, we need to do the calculation first. Okay, so same thing that we are doing, whatever the input data that we have, first we need to convert those particular input data into the vector that is called 512 vectors that we need to convert, and then those particular vector we can store into the boxes. Okay, now here as you can see the data that we have converted into the 512 vector, and we store into the boxes. Now after storing those particular input data, what we are going to do, we are going to send to the self attention. Now as you can see, for each word our self attention generate some types of the output value that is called z1, z2, and z3. Just keep in mind this particular point. Later part I will explain you, okay, how that we are calculating these three things. Okay, but right now whatever the input word that we have, let's say in our one sentence that we have the 1000 word, it means our self attention generate 1000 Z vector that our self attention can generate. Okay, now let's try to understand how that we can calculate the self attention. As I mentioned, in a self attention that we need to calculate three things. First one is a query, second one is a key, and third one is a vector. But how that we need to calculate those three things, query, key, and value? Let's try to understand those things now. Okay, so as you can see, now we are going to do the encoding. Okay, so encoding we all know how that we can do. So let's say here we have the two data that is called thinking and machine. Okay, we have the two word in one sentence that is called thinking and machine. So first convert this particular thinking into the 512 vector, store into the boxes, and then those particular vectors we can send to the self attention where we can do the processing to find out the score for each word, so that we can find out, okay, so in which word that we need to focus on. If the particular word score is higher, we can say we can focus on the higher score value word only, not the lower one. Okay, now let's try to find out how that we can calculate here. So as you can see here that we have one sentence, this particular sentence that we have, the animal did not cross the street because it was too tired, and here that we have the it. Okay, now as you can see, whenever we calculated the score, we are getting the multiple score. As you can see, multiple lines that we have. So these are the multiple score value that we have. Where we use the self attention to calculate this particular score, and based upon this particular score, whenever we have the higher value that we can point, okay, so this is the meaning, this particular it represents to this particular animal word based upon the score value. But the question is how that we can calculate this particular score. Let's understand now those things. Okay, so whenever we are talking about to calculate the score, so here you can see the first step that we have in calculating the self attention is to create the three vector from each of the encoder input vector, the embedding of each word. So for each word we can create the query and key vector. Just focus on the word, okay, important point, nothing else. So what we can do in a first step, whatever the input data that we are getting, those particular input data, first that we can convert into the vector, then we can calculate queries, key, and value. Three things that we need to calculate: queries, key, and value. Okay, now how that we can calculate these three things that is called query and key value? Let's try to understand those things. Okay, so here you can see we have the data, and this is the architecture that we have. Okay, so we have the input data that is called thinking and machine. Let me open my Epic Pen once so that I can write it down here as well. Okay, so where's it? Yes, now got it. Yeah. So here as you can see, we have the three things. First is a query. We have the three things that is called query vector, key vector, and the value vector. Three things that we have. We need to calculate the three things. So this particular query, yeah, Raviteja, go ahead, please.
Sir, Jai Durga asking Zoom link again.
Okay. Raviteja, please ask him to join first because it's a little bit difficult topic. Okay, so yeah, now are you there?
Yes, sir. She's joining.
Okay.
Yes, sir. She joined.
Okay, fine. So yeah, now let's start. So as you can see here that we have the three things as I mentioned. To calculate the score, we need to calculate the three things that is called query, key, and value. Query, key, and value. So here we have the query vector, we have the key vector, and we have the value vector. So here query represents, where is the big pen now? Here, this particular query represents the word that we are looking for. Query, this particular query vector represents the word that we are looking for from the other words. Because in a sentences, it might be possible that we will get the multiple words. In our sentences, it might be possible that we will get the multiple words. So let's say the multiple word that we have, that is called I love apple. So from this particular three words, what we are going to do right now, that we are going to calculate for this particular word, for this particular word. For this one, that we need to calculate the three things, that is called query, key, and value. Again, for the another word, that we need to calculate the three things, that is called query, key, and value. Again, for the other word, we need to calculate the same thing, query, key, and value. So what happened in query? In a query, that we are going to calculate, so that we are going to look the particular word from the other words, whatever the other word that we have in our entire sentences. This is called the query. Now we have the vector. So vector, it means whatever the word that we are going to represent, or whatever the features from our words that we are going to represent, those things called the value, a key vector. Those things called a key vector. Now after that, we have the value. So value vector, it means it store, I can say it's store, or it contains the actual information from our word. So let's say here that we have I, it means ki मैं. Here I love apple, it means mujhe. So this particular mujhe, this is the actual information that we have for this particular sentence, right? Not मैं. Mujhe is the actual information that we have for this particular sentence. So this particular value vector store only the actual information from our word, whatever the words that we are using. Okay, so this is the meaning that we have for the query, key, and value vector. Now let's try to understand how that we can calculate these three things, that is called query, key, and value. Okay, so again, I will take the same like neural network example so that we will get the better understanding. So as you can see, first of all, that we have the input data, that is called two. We have the one sentence, and in one sentence we have the two word, that is called thinking and machine. Two word that we have. So the first step, that we need to convert our data into the embedding vector, where we need to use a 512 embedding. We need to convert the input data into the 512 embedding vector. Same for first word and same for the second word, that is called 512. Now, whatever the input data that we are going to convert, those particular input data, vector, embedding vector data, we can do the multiplication with the weight. So let's say here I'm going to say x1 into wq equal to q1. x1 into wq equal to q1. So x1, this is called our input data, and this is called our weight for query. Just focus on the word. I'm writing wq. So input data, first input data, and weight for query, that is called query 1, q1, that is called q1. This is the value that we are going to calculate for q1. This is the output that we have, that is called x1 wq. Now let's say we are going to calculate for q2. Okay, let's say we are going to calculate for q2. In this case, we can say x2 into wq. x2 into wq. Okay, so input number 2, okay, x2, and the wq, that is called weight multiplication that we are going to do. Now let me represent as a neural network. So can we say like this one? So let's say here that we have the two input data, that is called, first one is a thinking, and second that we have, that is called machine. Now here I'm going to create a two input layer, first input layer and the second input layer. Now here that we have the thinking, and here that we have the machine. Now what we are going to do? We have some hidden layer here. First hidden layer h1, this is the h2, that is called second hidden layer, and then we can generate some types of the output. So what we usually do in a neural network, whatever the input data that we are going to pass via the input layer, first of all that we need to do the multiplication here. So whatever the data that we are going to pass to the next layer, in between we have some types of the weight. Let's say here that we have the W1, W12, W13, W21, W22. We have some types of the weight. We have some types of the weight. So whatever the input data that we have, so this particular input data definitely that we can send into the vector. So let's say the data that we have into the vector. So what we are going to do? First, we are going to do the multiplication this particular input data to this particular weight, and then this particular whatever the output that we will get, those particular output that we are going to send to this particular hidden layer here that we are going to store, right? Same thing that we are doing in this particular architecture here. So whatever the input data that we have, this particular input data that we are going to multiply with the weight, and then whatever the output that we will get, this is called the Q1, that is called query 1. So X1 into WQ equal to Q1. Clear guys? How that we are going to calculate the query? How we are going to calculate the queries? This is clear? Yes? No?
Sir,
Purnima,
can you
Raviteja?
Yes, sir.
one more
Yes,
time?
sir.
Okay, no sure. Let me repeat once again. So what happened whenever we are going to calculate the queries key and value, so we need to do the multiplication with input data and weight vector, whatever the weight that we have. So every time, whenever we create the neural network, let's say that we have, again, I'm going to create the another neural network. So here we have the neural network. This is the input layer that we have, and here we have some hidden layer. This is the first hidden layer that we have. We have the second hidden layer. Let's say we have some input data that is called X1 and X2. Now at the end that we need to send the numeric data. So what we need to do? We need to convert this particular data into the vector. So here we are going to convert X2 data into the 512 vector embedding. Again, X1 data that we are going to convert into the 512 vector embedding. So in this way that we will get the embedding. Let's say this is the 100 like 512 vector embedding that we have, and again this is the 512 vector embedding that we have. So what we do? Whatever the input data that we are going to pass, we need to pass to the next hidden layer in this way, right? So in between here that we have some weight that is called W1, W12, W11, W12, W13. Now this is the random weight, anything, random weight that we have, anything. Okay. Now again that we have W21, W22, random weight that I'm going to call. It means whatever the input data that we have, we need to do the multiplication with weight, and then whatever the multiplication output that we will get, we can store it here. Now in our scenario, what happened? Whatever the thinking and machine input data that we have, that is this one is a X1 and this one is a X2. Now whatever the input data that we have, this particular input data that we have converted into the vector, okay, into the vector that is called 512 vector embedding. Now this particular input data that we are going to do the multiplication with WQ. It means I'm talking about weight of query, because first of all that we are going to calculate for queries. So weight of query, it means here we are going to do the calculation input of X1 into WQ, that is called Q1, that is called query 1. Now clear everyone?
Yes, sir.
Yes. Now let's say if we want to calculate for query 2, in this case what we can do? We can say X2, that is called input number 2, into WQ equal to Q2. This is queries 2. So on. We have here 2 words. So that's why we have taken the simple example. In a real scenario, that will get the n number of the words in one sentence. Let's say 100 or 1000. In this case, what we need to do? We need to calculate Q1, Q2, 100 or 1000 times based upon the data. Every time we need to do the multiplication with weight of query. Then we will get the queries data. Clear? Now, queries,
Yes.
how that we can calculate?
Yes.
Now, second thing that we need to calculate the keys. So same thing that we need to do. Only we just need to change the weight. Previous time we used the WQ, that is called weight of query. This time that we need to use weight of Q, weight of keys. So X1 into WK equal to Q1. This is called a Q1. X1 into weight of key. Here we are going to calculate the keys. So that's why weight of key that we need to assign. Again, as I mentioned, weight is a random weight, anything. That's why we are changing the weight. And based upon the changing of the weight, that we are going to calculate the queries and the key. So X1 into WK. Now again, let's say if we need to calculate the values, In this case, we can say X1, that is called input data 1 into WV. It means that we are going to calculate the value 1. We are going to calculate the value for 1. X1 input and the WV, it means value for 1. Now here you can see, multiplying X1 by the WQ, weight matrix produce Q1. Just focus on this particular sentence. Multiplying X1, that is called our input data, by multiplying weight of Q, weight matrix produce the Q1. The query vector associated with that, we end up by creating the query key and value projection of each word in the input sentences. So same way, what we can do? We can do the multiplication X1 with WQ. It means that we are going to calculate the Q1. If we are going to do the calculation with X1 into WK, it means weight of key. It means we are calculating keys. X1 into WV, it means that we are calculating the values. Clear how that we can calculate keys, values and queries? We just need to do the multiplication with weight for the particular queries, keys and value. All done?
Yes, sir.
Yes?
Yes,
Yeah,
sir.
Ravi Teja?
Yes, sir.
Yes, sir.
Okay, fine. Now in this way that we can calculate the three things: queries, key and value vector. First step, this is called our first step. Now let's try to understand second steps. Okay, second steps. So here, as you can see, in a second steps, what we are going to do, first that we calculated the input data. After that we have the embedding, and based upon those particular embedding, that we are going to calculate the Q1, V1, Q1, K1 and V1, that is called queries, key and value. Queries, key and value. Now we need to calculate the score for each word. For each word, we need to calculate the score. So what happened in a score? In a score, that we need to do the multiplication. We need to do the multiplication with Q1 and K1. Q1 and Q1. Q1 that we are saying because we are talking about the input number 1. That's why we are saying Q1. Okay, so Q1, it means it represents what word that we are looking for from the other word. So other word, that is called machine, and this particular word that we are looking for. So here we have the output for the Q1, that is called thinking. Now to calculate the score, we need to do the multiplication with Q1 into Q1. What K represents? So K represents the features of the particular word. Features of the particular word, this particular keys represents. Okay, so here we are going to do the multiplication with Q1 into Q1. So let's say the output that we are getting, that is called 112. Output that we are getting 112. Now, second that we are going to do the calculation for Q1, that is called this one, into K2, this particular value, for the another value. Now as you can see, just compare here. We are talking about this particular thinking. It means that here we have the higher value, and whenever we use the other word, whenever we use the features for the other word, that we are getting the less score. Let me explain you in simple word. Okay, so let's say here in a session that we have the three peoples. Okay, so here let's create the session. Okay, so let's say that we have the session. In a session that we have the three features. Okay, so the first features that we have, let's say for the Purnima ma'am, second for the Ravi Teja R, and third for the Jaya. Now let's say here Purnima ma'am know SQL, machine learning, Python. Okay, now let's say for the Ravi Teja, let me change the color. Okay, so for the Ravi Teja, he know only Python and NLP. NLP. Okay. Now for the Jaya, let's say she know like machine learning and NLP. Okay. And here Python, ML, and this is SQL, right? So this is SQL. Now here I'm going to add something called like, let's say Power BI. Power BI. Okay. Now I need a person. I need a person. Okay. I need a person who know, let's say SQL, machine learning, and Python. Three things. I need a person from out of these three person. I need SQL, machine learning, and Python. SQL, machine learning, Python. Okay. Now let's say we have some value. Value, it means we have some information for the particular students. For the particular students. Okay. Now here let's assume we have the query, this particular query that we have like a subject like SQL, machine learning, and Python. SQL, machine learning, and Python. We have the features that is called query features like Purnima ma'am know each and everything in a detail. Let's say export label. Okay. Now let's say for this one, I can say export. Again for this one, let's say export. All the members, they have the export in a particular field. Okay. So here export, that is called query, and the subject, that is called key. Subject, that is called key. Now what I'm going to do, I'm going to do the multiplication. I'm going to do the multiplication with subject and export. Subject and export. I need a person who knows SQL, mathematics, and Python. So whenever we can do the multiplication for this particular three subject and the expert, definitely that we can accept the higher value because this is matched. All the subjects are matched here, whatever our expectation that we have. So let's say here I'm going to say 99% matched. Now here what I'm going to do, I'm going to add features here. So let's say here that we have the Python. So yes, we need a Python. Python, we needed Python. NLP, no, we are not need a NLP. So only the Python that we have. Apart from this one, the export. So here, let's say if I'm going to assign like something called 75%. 75%. Now for the Jaya, machine learning, yes, we need a machine learning. Python, it's not a Python. Let's say it's a Python. Okay, so let's say here Python that we have. So again, this is matched, but this is not matched. Other subject that we need, that is called SQL. So let's say here I'm going to say something called, let's say 85%. 85%. Okay. Now based upon this particular score, which person that becomes selected? Definitely the first one, because here that we have the highest accuracy, highest score that we have. Can I get yes or no? Highest score that we have, right? Same thing that we are doing here. Same thing that we are doing here. Whenever we are doing the calculation, a multiplication with query and key1. So query is a subject and key is a expertise. Okay, query is a subject and key is a expertise. Based upon this one that we are getting the score that is called 112. And based upon this one here, we are going to select the queries key 1 and the key that is called K2. So here we are getting the score that is called 96. So definitely that we need to select the first one. Can I get yes or no?
Yes, sir.
Yes. Okay. So based upon
Yes,
this
sir.
particular score, so in this way that we need to do the calculation to calculate the score. First, we need to calculate the queries where we need to do the multiplication with query, like input data into the weight of query, input data into the weight of keys, input data into weight of values. And after that, to calculate the score, we need to do the multiplication with queries into K1. Queries into Q1. This is the first step that we have. Now, again, you have the question, okay, but where is the use of this particular value? Where is the use of this particular value? Right. So right now, as you can see that we are getting only a score. But as for the architecture, if I show you again, as for the architecture, what we need? We need the value of Z. Value of Z. Right now we have
Yes,
just
sir.
calculated the only one thing that is called score only, but now we need the Z value. Let's think how that we can calculate. So to calculate the Z value, we need this particular values information. And this particular values contains the actual information of the particular word. Actual information. Okay. So this is the second step that we are where we are calculating the score. I hope till here everyone clear. Yes.
Yes, sir. Yes, sir.
Okay. Fine. Now after that, third and fourth step that we are where we are going to divide the score by 8. We are going to divide the score by 8. Again, this is not any like default value. I will show you how that we are using 8 here in our upcoming session, because we need some other calculation as well. Okay. So here right now what we are going to do, whatever the score that we are getting, those particular score that we are going to divide by 8. So the square root of the dimension of the key vector used in the paper, that is called 64. Okay. So the square root of the dimension, the research papers, they have used 64. And whenever we calculate the root of, 68, we will get 8 value. Root of 68, that is called 8. Okay. So that's why here we are using the 8 here. 8. Okay. We are going to divide by 8 because the researchers, they have taken the dimensions key vector in a research paper that is called 68. Okay. So if you want, you can just divide this particular data, this particular score, that is called 112 divided by root of 68. But again, if we calculate root of 68, that we will get 112 divided by 8. So that's why we are going to calculate the 8 value here. More detail we can discuss in our upcoming session. Okay. So in a third and fourth step, that we can divide the score by 8. So here you can see what we are doing. We are going to divide the score by 8. So whenever we can divide like 112 divided by 8, that we will get 12, 14, and 96 divided by 8, that is called 12. Okay. Now after that, what we can do, whatever the output that we will get here after the division of the score, we can use the softmax function. We can use the softmax function, and after applying the softmax function, this is the output that we will get. This is the two output that we will get, that is called 0.88 and 0.12. At the end, again, as you can see, we have the highest score for this particular data, highest score. It means this particular queries and key that we are going to focus on the thinking word based upon this particular score. Okay, again, this is the softmax score. This is not a final Z output. This is only the softmax score. So as
Sir,
you can see, yes, David, go ahead, please.
sir, like the Softmax, how did we get, sir? Like 0.88.
Softmax that we are using to do the normalization, to normalize our data. If I show you here, so as you can see how that we are calculating here. So here, okay, so here we are not happy. Okay, fine, no issue. So what we are doing here, so whatever the data that we are getting, I will show you the formula for this one. So if
Yes,
I
sir.
scroll down, as you can see, this is the formula that we have. This is the formula that we have, where we have the query. Okay, whatever the input data that we have, first of all, input data that we are going to do the multiplication with weight of query, input data, weight of keys. Now whatever the this particular output that we will get, this is this one. Okay, so weight of query, input data into the weight of query, input data into weight of queue, divided by is divided by 8, that is called root of 64. Okay, root of 64, that we can say 8. And then we are going to put it down this particular whatever the data that we will get under the softmax to normalize our data. We are just doing the normalization here. Softmax activation function, I hope you have know like what is softmax activation function. We have already learned under the NLP session, right?
Yes,
Activation
sir.
function, right? So here we are
Yes.
using the softmax activation function to normalize our data, or I can say to calculate the probabilities for the particular word. Probability, it means the score. So if I show you here, so as you can see what we are doing here. So here we are getting the probabilities for thinking word and the probabilities for thinking word, where we are using the Q1 into K1, and here we are using the Q1 into K2. First that we are using K1 into K1, and second that we are using Q1 into K2. So this is the score that we have. Probability score for Q1 into K1 and probability score for Q1 into K2. So softmax we are using to normalize the data and to calculate the probabilities for the particular score. Now clear? I will show you
Yes,
one
sir.
more
Yes, sir.
example. Okay, in some time. Okay, fine. Now in this way, first that we can do the multiplication with Q1 into K1 and Q2 into K2. Then we can do the division by 8. Okay, after that we can use the softmax to calculate the probabilities. Now after calculating the probabilities, in a sixth step that we can weight sum up the weight of value vector. We can sum up the weight of the value vector, and this produce the output of the self attention layer at this particular page position for the first word. For the first word, after sum of the weight value vector, it means I'm talking about this particular things. Okay, value. Okay, so as you can see, what we are doing, whatever the softmax output that we are getting, now we are going to sum up with the value. So V1 and V2. Then we will get the final output that is called Z1. And Z2. Z1 and Z2. Because here we have the two softmax value. This is the Z1 and this is the Z2. So whenever we can sum up softmax into value, then we will get the final sum vector that is called Z1 and Z2. If I conclude, so here what we are doing, let me zoom out little bit so that I can show you the entire architecture. Yes, as you can see, we started from here where we have the input data, two input data, thinking and machine. First we converted into the vector, and now whatever the vector that we are getting, we are going to do the multiplication with input data into the weight of Q, that is called Q1, input data into weight of K, that is called K1, input data into weight of V, that is called weight of value, that is called value 1. Then we are going to calculate the score equal to Q1 into K1. Then whatever the score that we are getting, that we are going to do the division by 8. Okay, so Q1 into K2, that we are going to do the division by 8, not a root, it's 68, let's write. Okay, and we will get the 8. Now whatever the output that we will get, this particular output that we can use to calculate the probability using the softmax. So here I'm going to write softmax into Q1 into K1 divided by 8. Okay, and after that we are going to do the multiplication with value, and this is called the final Z1. If I write if I write the phrase formula here, so this is the formula that we have for Z1 equal to softmax into Q1 into K1 divided by 8 into value. Now what is this particular Q1 into K1? That is called a score. This is the division. Here that we are going to calculate the softmax, and after that we are going to do the multiplication to get the final Z. Clear guys, how that we are calculating the self attention?
Yes sir, clear.
Yes, sir.
Now clear?
Yes sir.
Yes, sir.
Yes. So here we are talking about only single word. Now just think, whenever we are going to train or whenever we are going to build any types of the application, in one data set, we are getting millions and billions of the record. And in this particular millions, billions of the record, in one sentences, that we are getting hundred and thousands of word. It means for each word, we need to calculate what? We need to calculate Z value. Okay, and whenever we say we are going to calculate for each word, we can say that we are doing the multi-head attention. Here we are talking about single attention, that is called self-attention. Whenever we use all the words and whenever we do the multiplication with the other weights, we say multi-head attention. We will discuss, don't worry. Okay, we can discuss. Right now, let's try to understand these particular things in a detail. Okay, so in this way that we calculate each and everything. Okay, now after that, whatever the Z data that we are getting, whatever the Z output that we are getting, those particular Z output that we send to the feed forward neural network. So just think how many steps that we are doing under the self attention. Minimum I can say approx 7 to 8 steps, right? 7 to 8 steps. If I include everything like encoding, positional embedding, then query, key, value, let's calculate. Embedding, positional embedding, queries, key, value, score, okay, then division by 8. After that, softmax activation function, softmax to get the probability, multiplication with the values, and then we will get the final z. It means total 10 steps that we are doing under the self attention to get only one value, that is called z. That is called z. And this particular z represents, okay, a particular word, like it represents to animal or street in our data. In our data. Okay. So to get the attention for the particular word in a sentences, that we are doing the entire calculation, that is called self attention. Clear? Clear?
Yes, sir.
Yes. Okay. Now let me give you one more example. Let me give you one more example, because as I said, the first session, this particular architecture, it will take approx 4 to 5 sessions, even sometime more than that. Okay, so let me explain you one more example so that you can grab each and everything. Okay, so here I'm going to take one simple data that is called, let's say, the one sentence that we have, that is called the cat sat on the mat. This is the simple sentences that we have. Now what we need, we will focus on the word that is called cat here. We will focus on the word that is called cat, and then we can calculate the self attention. We can calculate the self attention for this particular cat word. Okay. Now what I'm going to do, first of all, let's try to do the embedding. First of all, let's try to do the embedding. So here I'm going to write like this one, the cat sat on the mat. Okay. Now what I can do, let me put it on one line. Okay. So this is the word that we have. Now what I can do, we are doing the encoding here. We are doing the encoding. So what I can do, encoding, or I can say the embedding. Okay. So what I can do, let me put it down the random value. So I'm going to put it down the random value like 1, 0, 1. Random in embedding that I'm going to put 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1. Okay. 0, 0, 1. So this is the embedding that we have. Now after getting the embedding, what we need to do? We need to calculate the query key and value. So query, key and value. These three things that we need to calculate. So what I'm going to do, I'm going to create the random weight. So let's say WQ. Random weight that we are going to create. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now for the WK, that is called weight of key. So 0, 1, 0, 1, 0, 0, and 0, 0, 1. This is for weight, weight of key. Now weight of value, let me put it down below. Weight of value. So here 1, 1, 0, 0, 0, 1, and 1, 0, 1. This is the random weight that I created. Okay. Now what we can do? We can do the like matrix multiplication to calculate the queries, key and value for each word. In our data that we are using the cat word. We are using the cat word. So what I'm going to do, here I'm going to calculate first of all queries for cat Okay, queries for cat. So let me take the data. So cat that we have, that is called 0 0 1 1 1 0 1 1. So here I'm going to say 0 1 1, weight that we need to do the multiplication. So into weight of query, into weight of query. Okay, where the weight of query that we have, that is called 0 1 1. Weight of query, that is called 1 1 1. Okay, 0 1 1 1. Now we can calculate the key for cat. Okay, now here next value again that we have the cat value, that is called 0 1 1 1, because the input value that we will get the same value, right? Into weight of k, that is called weight of query. So here whenever we can do the multiplication with weight of query, let's say the random data that I'm going to take right now. So 1 0 1. Okay, weight of key, that is called this one. Weight of q, that is called this one. Entire data that I'm going to select. Okay, now this is the output, random output that I'm going to get right now. Okay, now value for cat. So what we can do, again input data same 0 1 1 1. Okay, into weight of value. So this time that we can take this particular data, and after calculation, let's say that we are getting the output that is called 1 1 1 1 1. Okay, so this is the weight of cat that we are getting. Sorry, is a value of cat. Okay, so query key and value for the cat. Now what we can do, now we can compute the score. Now we can compute the score, that is called q1 into k1, q1 into k1. So here I'm going to calculate the score. So in a score, what we can do, a score for cat. So a score for cat that we are going to calculate. So q1 value, that is called 0 0 0 1 1 0 1 1. The formula that we have, q1 into q1. So q1 value, that is called 0 comma 1 comma 1, and k1 that is called 1 0 0. So 1 0 1 1 0 1. Whenever we can do the multiplication, so in this way that we can do, what we can do, we can transpose. So 0 1 1, and let's say if we are going to transpose the data, in this case that we will get something called not this one, like this one, we can put it down 0 0 1, and we are going to transpose this one. So we will get the output something called, whenever we can do the multiplication, 0 into 0 0 into 0, and then 1 into 1 and 1 into 0. So that is called one output that we will get. Let's say the random one output that we are getting. Okay, right now. Now what I can do, so here we are going to calculate for the okay, so cat. Now what I'm going to calculate the score. So a score for cat to cat, cat to cat. This is the cat to the that we are going to calculate. The, if I show you, so here that we have the value, and the value that we are getting, that is called 101, and the same 101 that we have taken here. So this is the cat with respect to the we are going to calculate. Here cat with respect to cat we are going to calculate. Okay, so here I'm going to say 0 1 1 into 101. Again that we are going to do the transpose. After calculation, that we will get the value that is called 1. Now if I show you here, you can see that we are getting the 2 score. We are getting the 2 score. How? First that we have calculated q1 into k1, and then q1 into k2. Same thing that we are going to calculate. It means here that we are talking about two word. First one thinking, second one is a machine. That's why here I'm going to calculate with respect to cat and the. First word cat, second word that is called the. Here cat, second word that is called cat. Now this time I'm going to calculate the score for cat with respect to sat. Cat with respect to sat. So the cat value that we have 0 1 and 1 into, what is the value for sat? Sat 1 1 0. So here I'm going to say 1 1 0 transpose. So let's say the output that we are getting 1. So 1 1 that we are getting for all words. Okay, 1 1 that we are getting for all the words. So this is the attention score that we are getting. Now what we need to do? Now next step that we need to apply the softmax to normalize the score. Softmax that we need to apply. So here softmax score equal to score divided by summation of score. This is the formula that we are getting, multiple input. Okay, so if we are going to calculate the score for cat, in this way that we can do. Okay, so here the cat score that we have, that is called after doing the calculation, let's say that we are getting something called 111,010. This is the cat score that we are getting. Now what we can do, we can apply the softmax here. After applying the softmax, that we will get the normalization data. So let's say that we are getting 0.2, 0.2, 0.2, 0.240, let's say 0.1, again 0.2 and 0.1. After normalization, this is the data that we are getting. Now what we need to do, next step, we need to divide by 8, weight sum of value, weight sum of value. So whatever the probability that we are getting, we need to calculate the value. So what we can do, we can just multiply with the value. So 0.2, this is the first value, into what is the value here, value that is called 111, right? Value that is called 111. So what we can do, we can do the calculation, multiplication with value that is called 111 for all the data, for all the data. And then same thing, whatever the output that we will get, this is called the sum, that is called Z1 value. And then same thing that we can repeat for other words, that is called the sat on the mat. Clear everyone? How that we can do the entire calculation? Or
Yes,
is
sir.
confusing?
Yes, sir.
Clear, sir.
All clear? Jaya?
Yes, sir.
Okay. Fine. See, this is the little bit confusing, I know, because this is the advanced architecture that we have. And again, as I mentioned in a first session, if you are able to explain this particular architecture, and especially for self attention and the multi-head attention, no one going to reject you during the interview. Okay. Even let me tell you one thing, like on the Google, whenever you search this particular topic, okay, only till now, like if I talk about like my entire IT career, okay, so in my entire IT career total, I have the approx 6 years of experience, and entire IT career, I just saw one blog where you will get each and everything, and only one mentor, he had uploaded the video on the YouTube, Sudhanshu sir. Okay, only two guys. Apart from these two guys, whatever the YouTube videos that you will get on the YouTube or the blog that you will get, they have just explained the very basic things, not a mathematical calculation.
Sir,
Okay, even
Sudhanshu sir only teach Python, right?
no ma'am, first like in 1819 they teach this particular things, and from the Sudhanshu sir I learned this particular calculation and the research paper. Okay,
Sir,
and
he
whatever
didn't say,
yes ma'am.
I didn't say his.
No, like in like 19 they have taken the NLP session. After that, like another mentors they have taken the NLP and the computer vision session. When they started the iNeuron, they took the like NLP session in
Okay.
19 or 20, I thought, huh? 1920. Okay, but yeah, apart from the Sudhanshu sir and other like Jailmar blog, you can't get this types of the explanation anywhere on the Google. Okay, so it's a little bit difficult. That's why even the people, they didn't upload the videos on the YouTube, or they don't write the blog, they just write the simple things. Okay, so try to understand a little bit. Okay, fine. So in this way that we can calculate the entire self attention. Okay, now here you can see that we have some like calculation, matrix calculation, how that we can do. So here we have the input data into the vector, where the vector that we have, that is called 512. Again, that you need to remember this particular word. In an interview, it might be possible sometime they ask, okay, so whatever the input data that we are going to convert into the embedding vector, how many vectors that we need to use? Okay, so you need to point, okay, so we need to use 512 vector only. Okay, so 512 vector into weight of q, that is called query. Input data into weight of q, that is called weight of key, that is called keys. Input into weight of value, that is called value. Okay, so in this way that we do the entire calculation. Now whatever the output that we are getting, we can calculate the score with the help of multiplication of queries into keys divided by 8. Then we can apply the softmax to get the probability. We can apply the value to get the final Z output, that is called self attention output. Clear, guys? Till here?
Yes, sir. Clear.
Yes? Fine.
Yes,
So
sir.
yes, this is all about the today's session. Just try to digest this particular point. Okay, I'm not going to cover the multi-head attention. Again, it will take max to max 10 to 15 minutes. Okay, but no, I can't cover right now. Just try to digest this particular point. Okay, so that even you can grab in the next session, you can grab this particular multi-head attention. It's the again little bit advanced. Okay, so self-attention, I can say the first layer that we are talking about, and multi-head attention is the, I can say, the advanced layer that we have. Okay, and then same multi-head attention, the researchers, they have used in the research paper. Here, as you can see, multi-head attention. Okay, multi-head attention. So the self-attention, this is the first layer that we have to understand the complete attention concepts. Okay, so what you can do, I will upload this particular recording like after this, like in next 2 to 3 hours. Just go through the recording once before the tomorrow session, so that we can cover the multi-head attention in a detail tomorrow.
Okay, sir.
Okay, if possible, what you can do, whatever the calculation that I did for the cat example, for this one, what you can do, try to calculate for the others if possible. Any other words, you can just select any other words and do the calculation one by one. Random data that you can take, random weight for keys, queries and values, and then do the calculation. If you want, use the Google, use the chat GPT. I don't have any issue, but just come up with some output, mathematical calculation.
Okay, sir.
Okay, again, whenever we can implement, we just need to write 2 lines of the code. That's it. But we need to understand this one, this particular mathematics. Okay, because let's say if you are working as an NLP engineer, and if you're a manager of or if any juniors, they ask, okay, so how this particular architecture works. Okay, in this case, that you need to explain. Or let's say in an interview, you need to explain this particular architecture. Or to learn any other SOTA model, any other NLP models or LLM models, you need to understand this particular architecture. Okay, so just watch this particular video till the end once again. Okay, and do the calculation for at least one word. I will cover one more calculation in next session. Okay, but come up with one calculation.
Sure, sir.
Okay, everyone, clear?
Yes, sir. Clear.
Okay, fine, guys. So let's conclude here, and tomorrow shall we connect 7 p.m. if it's fine?
Yes, sir. Sure.
Okay. Fine, guys. So let's connect tomorrow 7 p.m. Okay, and from the next week onwards, like from the Monday onwards, whatever the timing that we have, we can connect on the same time.
Okay, sir.
Yes, sir.
Okay. Okay. Fine, guys. So let's conclude. See you tomorrow. Okay. Yeah. Okay, guys. Thank you. Thank you.